All right, lesson 3, homework video. Find the derivative function. We need to use the product rule. We have a product. X cubed being the first function, cosine x being the second. The derivative, y prime, make sure we're comfortable with dy dx, being the derivative of the first times the second, plus the derivative of the second, tangent subgenerator for cosine is negative sine, times the first. Do not multiply the x and the x cubed together. They cannot be multiplied together. This x is being tied up by the sign. If anything, if you'd like to, you could factor out a x squared, but it's not necessary. Okay. Second guy, x sine x. Have to use the product rule because this is the product of two different functions. We have the first, we have the second, the tangent slope generator, y prime, or dy dx, derivative of the first times the second, plus derivative of the second times the first. Do not multiply this x and this x together. That is wrong. Okay. All right, quotient rule. I have a quotient. I can't simplify this because of the subtraction in the denominator. Instead, I just need to take the derivative. Reminder to be familiar with this notation for taking a derivative. The derivative of f is f prime. I probably should write that up here, but you know, it's just notation you need to be familiar with. If you were asked to do this, you would know what to do. You don't have to do it. Okay. We're going to say this is the top and this is the bottom. It's very similar if you thought of this as f and g. It's like the derivative of f times g. Instead of plus derivative of g times f, it's like minus the derivative of g times f. Anyways, derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Now, this is great. You can leave it like this, but simplifying the numerator is usually what you'll have to do for a quiz or for for a multiple choice question on a test. So let's just practice simplifying the numerator. So I'm going to distribute the 3x squared, giving me 6x cubed minus 9x squared. Then this would be minus 2x cubed over. I'm not going to distribute the denominator because it actually makes it more complicated than this factored form, actually. That's 2x minus 3 squared. And then I'm going to just combine my x cubes. The 6x cubes minus the 2x cubes is 4x cubes. And if I wanted to factor out like an x squared, I could do that as well. Okay, so be prepared for a quiz. This is satisfactory. For a test, a multiple choice problem, you will need to be forced to be prepared to do this. All right, so x over 1 minus x, derivative of the top times the bottom, minus the derivative of the bottom. The derivative of 1 minus x would be negative 1 times the top, all over the bottom squared. This is fine, but let's just simplify a little bit. I got 1 minus x. This is minus a negative or plus a positive, plus x over 1 minus x squared. And this numerator simplifies to just be 1 over 1 minus x squared. It's a lot nicer looking than the previous one. All right, we got sine x over x, we got x over sine x. We got to use the quotient rule for both. Let's take the derivative. Let's get the derivative of the top times the bottom. Don't multiply those x's together. Minus the derivative of the bottom times the top. All over the bottom squared. Maybe just make the numerator look nicer, but there's nothing I can do to simplify. I'm just going to leave it like this. Okay. This guy. The tangent slope generator for g of x, g prime of x. Plugging values into g prime will give us tangent slopes of g. Derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Something we need to know for the future, right now it's not that important, is that if I have the sine of x quantity being squared, you could rewrite this. The denominator as sine squared x. Okay? Can't simplify anything, so I wouldn't. I'm good. Done. Leave it like that. Got this big product. Need to use the product rule. First, second, derivative of the first times the second. Huge second, but that's correct. Plus, derivative of the second. Use parentheses. This is the derivative of the second, 4x cubed plus 8x minus 3 times the first, x squared minus 2. One thing I was kind of a little bit upset with my quotient rules is the fact that none of them had to distribute the negative. Make sure you remember, and maybe there'll be an example later, where like if there's a lot of stuff going on after this minus sign, you gotta distribute the negative to all of your terms when you simplify. So just be careful of that. Anyways, I'm not going to distribute things here. H prime, this is a tangent slope generator. Leave it. I'll be able to plug values into this. It'll take me a while to distribute and simplify. Okay, find the slope of the tangents of the functions on the previous page of the following point. The y's at pi over 2. Where are my y's? All right, there's a y, there's a y. All right, fun. Here we go. So I'm going to write dy dx at pi over 2. That'll be pi over 2 squared times 3 cos pi over 2 minus pi over 2 sine pi over 2. Okay, this is cool. This is, I'm going to write it as pi over 2 squared still. I'll tell you why in a second. Cosine pi over 2 is 0. Sine of pi over 2 is just 1. So I have minus pi over 2. So we got pi over 2 squared times negative pi over 2. I can actually leave that negative out in front and write it as negative pi over 2 cubed. Pi over 2 squared times pi over 2. You could also have simplified this if you wanted to square things. This is just pi squared over 4. Make sure you know to square the top and the bottom. And then you multiply by another pi, you get pi cubed. Multiply by another 2, you get 8. So this or this is fine. All right, this y, I'll write it as y prime at pi over 2. It's the sine of pi over 2 plus pi over 2 cos pi over 2. Sine of pi over 2 is 1. Cosine pi over 2 is 0, so it's just 1. Okay, let's see, what's the next one? F prime of 2. Okay, well, like, I could have plugged 2 in here, but that doesn't matter. Plug it in here, plug it in here. It's actually just as easy to get. F prime of 2, let's see. Let's do it in the top. So I get 4 times 3 is 12. 2 times 2 is 4 minus 3, which is 1. So I have 12 minus 8 That's 2 cubed times 2 is 16. So 12 minus 16 over 2 times 2 is 4 minus 3 is 1. 1 squared is just 1. So this is negative 4. Let's see if I'd get negative 4 if I plugged it in here. So I get 4 times 8 minus 9, negative 4 over 1. Yep. So either way, you get that correct answer, whether it's simplified or not simplified. So cool. G prime of pi. Oh, I guess I have to do both of my f's at 2. So f prime of 2 here. This is easy. 1 over 1 minus 2 squared. That's just 1 as well. Negative 1 squared. G prime of pi. All right, G prime of pi. Pi cos pi minus sine pi over pi squared. Cos pi is negative 1. Sine of pi is 0. So negative 1 times this pi is negative pi over pi squared. That'll simplify to be negative 1 over pi. One of the pi's will cancel with one of the pi's. Cool. So that's the tangent slope of G. And H prime. Okay, got to do this G. G prime of phi. Sine of pi is 0. Minus pi cos pi. That'll be a positive 1. I'm going to have a 0 in the denominator. So and this is a good example. I end up with positive 1 over 0, or 0 squared. Does not exist. It's important. I shouldn't have asked you pi for this situation because g of pi is pi over 0, which means it's a vertical asymptote. It's a non-removable discontinuity. So no point, no tangent slope. Not continuous, no tangent slope. I'm going to leave that like that. It's important to remember that. And then h prime of 1, here we go. H prime of 1, 2, 1 plus 4 minus 3 plus 1, plus 4 plus 8 minus 3 times 1 minus 2. Okay. 5, 2, 3, 6, plus 12, 9, negative 1, negative 9, negative 3. The slope of the tangent to h at 1 is negative 3. That's great. All right, that's right. An equation of a tangent line. We remember for an equation of a line, you need the format of a line. Y minus y1 equals m times x minus x1. This is the point slope form. Remember, the x is just going to be 3 pi over 2. We're given that. The slope will be our tangent slope generator at 3 pi over 2. And the y-coordinate will be just the point on my function at 3 pi over 2. Okay, so we just need to fill in that information. So let's start with the tangent slope generator. I'm going to call that f. So this would be f prime. I have to use the quotient rule, the derivative of the top times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. Don't love the happy face there. Oh, that's not better. Lines are tough with a slate. Okay. Bottom squared, 3 pi over 2 squared. Let's see what I get. Oh, sorry, bottom squared. I'll write it as x squared. Now I'll plug in 3 pi over 2. So negative sine 3 pi over 2 times 3 pi over 2 minus cosine 3 pi over 2 over, see if I can do it this time. Here we go. 3 pi over 2 squared. Sine of 3 pi over 2 is negative 1. So I got negative 1 times 3 pi over 2. That's just going to be a positive 3 pi over 2 in the numerator here. Minus the cosine of 3 pi over 2, I need to know is 0. Remember, 3 pi over 2 is down here. The horizontal distance is 0. The vertical distance is -1. Okay. The denominator is 3 pi over 2 squared. Well, if I just disregarded this and I have 3 pi over 2 divided by 3 pi over 2 squared, we will just have simply a 3 pi over 2 in the denominator. So I'll have 1 over 3 pi over 2, which I can simplify to be 2 over 3 pi. This is something that's like totally fine to get. That is the slope of my tangent to this function at 3 pi over 2. All right, so y minus equals 2 over 3 pi. X minus 3 pi over 2. Now, let's just find the y-coordinate. That's all I need to do. The y-coordinate would be f of 3 pi over 2. I'll do it over here. F of 3 pi over 2 is just cosine 3 pi over 2 over 3 pi over 2. Again, the cosine of that vertical is 0, so this is 0. So my equation is y minus 0 equals 2 over 3 pi x minus 3 pi over 2. To make myself feel better and to feel great, I'm going to graph cos x over x and my tangent equation 2 over, in parentheses, 3 pi, so that we're dividing by 3n pi, times x minus 3 pi over 2. Close. There's cos x over x right there. That's at 3 pi over 2. Let's see, watch. Trace 3 pi over 2. It actually will work out. Order of operations, your calculator will multiply the 3 and the pi first. Right there, let's zoom in right there. Yeah, beautiful. See that tangent line right at that point. Exactly what we want. Okay, find the equation line to this at x equals 4. Fancy. All right. Once again, I need an equation of a line, so my end goal is a y minus y1 equals m times x minus x1 equation, where x is 4, y1 is f of 4, in this case I'll say it's y of 4, and m is y prime of 4, right? It's just the tangent slope and the point on the function at which the tangent slope is passing through. All right, well, let's just go about it the opposite way. Let's find the point first. So I got root 4 over 4 squared minus 12. So that is 2 over 4. That is a half. Okay, so that's great. Now let's find y prime. So go to the top. 1/2 x to the negative 1/2 using the power rule. Times the bottom, x squared minus 12. Minus, go to the bottom, 2x, times the top, root x, all over the bottom squared, x squared minus 12 squared. Kind of messy, but I'm actually not going to simplify this too much, because the more I simplify, the more mistakes I might make, and I just need to figure out what this tangent slope is at 4. So I'm just going to leave this with one exception, this negative exponent. I need to know that this is 1 over 2 root x, or 1 over 2 x to the 1/2. That'll help me when I'm doing my calculations. So I'm going to just rewrite it like that, and then I'm going to plug in 4, and I'm going to calculate. Now, this all needs to be done without a calculator, so we've got to do a little bit of arithmetic here. Here we go. Y prime of 4 is 1 over 2 times root 4, which is 2, so this is 1/4. This is 4 squared, which is 16, minus 12, which is 4. That's nice. Minus 2 times 4 is 8, times root 4, which is 2. 8 times 2 is 16, over 4 squared, 16, minus 12 is 4. Squared is 16. So I end up with a slope of 1 minus 16 over 16, which is negative 15/16. Okay, so with all that being done, my equation, I think, is y minus the y of 4 value, which is 1/2, equals my slope, negative 15/16 x minus x1. To feel good about myself, I will do the work and graph and calculate. Root x over x squared minus 12, close parentheses. Solving this quickly for y, negative 15/16 x minus 4 plus 1/2. Oh, man, it's already zoomed for me. There it is, right there at x equals 4. Boom. There's a beautiful tangent line. Okay, so this is the instantaneous rate of change of this function at 4. We'd say at x equals 4, the function is going down 15/16 of a y per x. And we found the equation of the line. Great, this is a great question. I'm very happy to see this question. Find the equation of the line or lines that are tangent to this and parallel to this. Okay. That means my tangent slopes, my y primes, need to equal the slope of this line. I'm going to write it out. Tangent slopes need to equal the slope of the line. This is my line. I don't know what the slope is, but I can figure it out by subtracting x and solving for y, because I'll put it in y equals mx plus b form, or I will put it in a form where I can take the derivative of y and just get negative 1/9. So my tangent slopes need to equal negative 1/9. My tangent slopes are formed by a tangent slope generator. The tangent slope generator, I have to use the quotient rule, derivative of the top times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. Now, to solve this equation, it seems difficult. This is when simplification is fairly necessary. X minus 1 minus x. Make sure we distribute this negative. If there's like something else here, you got to make sure the negative gets distributed to both of those terms. I don't have that situation here, but that's a failure of me and my examples. So I just want us to be careful. This will be over x minus 1 squared, and this needs to equal negative 1/9. X minus x is just the negative 1 over x minus 1 squared. Negative 1 equals negative 1/9. Boom. This is an equation that I could solve. Now, there's multiple ways to solve this equation. I had an example in our notes for this. We can flip both sides and take the opposite of both sides, and we get x minus 1 squared equals positive 9. We could either square root both sides. Don't forget the plus or minus, because it's the unknown squared. Or distribute everything. Set it equal to 0, factor to solve. I'm going to do the more labor intensive, which I think is the distributing everything. This is x squared minus 2x plus 1 equals 9. I will then write it as x squared minus 2x. Subtract 9 from both sides. I get minus 8 equals 0. This factors to be x minus 4x plus 2 equals 0. I get my two x coordinates, x equals 4 and negative 2. If I square rooted both sides, I'd get x minus 1 equals plus or minus 3. It should be plus or minus on the left side, and then I move it over to the right side. If I add 1 to -3, I get -2. If I add 1 to 3, it gives me 4. Okay? These are my x coordinates, but I want equations of the lines. So here comes my equations. I know 2 things already for these equations. I know the x coordinates are going to be either -2 or 4. I know the slopes are going to be -1/9. I could double check that, but I literally just solved an equation where my y primes produce -1/9. If I plugged in -2 or 4 into y prime, you will get -1/9. That was the whole purpose of the equation. All I need to know is my y coordinates. This, I need to find y of -2 and y of +4. Okay, so let's go x equals -2. Y of -2 is -2 over -2 minus 1 is -3. So this is 2/3, giving me my equation y minus 2/3 equals -1/9 x plus 2. And then if x equals 4, y of 4 is 4 over 3. So I get y minus 4/3 equals -1/9 x minus 4. Don't believe me? Let me show you. X over, in parentheses, x minus 1. And let's do the first equation, the -1/9 x plus 1/9. And then my other 2 equations, -1/9 x plus 2 plus 2/3, and the -1/9 x minus 4 plus 4/3. We got some beautiful lines here. That's the equation of the graph of x over x minus 1. It's got a horizontal tangent at 1. We know that. The red line is the line that we don't really care about. It's the line where, boom, it's not going to be tangent to the function. But then we got these 2 lines, the black line and the pink line, that are parallel to that line and tangent to our function. This is phenomenal. We did a great job. Same thing. Fantastic. Equation of the line of lines. I hope that we have to distribute some things here when I take the derivative. Let's see. All right, I'm going to solve. So it's the same question as before, so I'm not going to spend as much time going through the process. There's the equation of the line. I need my tangent slopes to equal that slope. Let me make sure I subtracted x divided by -2. Yep, okay. So my tangent slope generator, derivative of the top times the bottom, minus the derivative of the bottom times the top, yay, all over the bottom squared. I say yay because I have to distribute this negative. This needs to equal 1/2. So I got x plus 1 thing froze. It's coming back. Hope it comes back. There it is. All right, x plus 1. Now watch. If I distributed this 1 first, and I wrote it as x minus 1, make sure you distribute this negative to the x minus 1. What I like to do, and this is just my personal preference, you do not have to do this, but I would recommend it, is whenever you see a subtraction symbol, man, get rid of it, make it add the opposite. make it add the opposite. That way I know I'm distributing a negative 1 to both of these terms. This is a negative x. This is a positive 1. That's the value everybody messes up. They think it's a negative 1 and they get 0. So fantastic. I'm glad we had an example where we had to distribute the negative. We got x plus 1 squared. Still needs to equal 1/2. But watch, if I simplify the numerator, I get 2 over x plus 1 squared equals 1/2. Okay. What should I do? I could flip both sides, and sometimes that's better just to get everything into the numerator. This is the same as cross multiplying. I don't like to use the term cross multiplying because sometimes students do it when fractions are supposed to be multiplied together, like straight across. So it's like they think of cross multiplying every time. So it's an equation. Let's just solve the equation. You're allowed to take the reciprocal of both sides. Boom. I'm allowed to multiply by 2. Again, 2 ways to do it. Square root or distribute. If you root, you should get a plus or minus 2. If you distribute, factor after you set things equal to 0. This is x plus 3x minus 1. I get, after subtracting 1 from positive 2 and from negative 2, negative 3 and 1. Fantastic. Here are my equations. Y minus y1 equals m times x minus x1. I know my x's are going to be at, what did I say? Negative 3 and 1. My slopes I know are going to be 1/2. My y's are going to be my y at negative 3 and my y at 1. Okay, so let's go with x equals 1 first. My function is x minus 1 over x plus 1. So y of 1 is 0 over 2, which is just 0. So I have y minus 0 equals m. You don't have to put the minus 0, obviously. X minus 1. And then when x is equal to negative 3, y of negative 3, not negative 1, negative 3, is, let's see, negative 4 over, plug in negative 3 plus 1, negative 2. That's positive 2. So I got y minus 2 equals 1/2 x plus 3. I'm going to graph them too. I'm doing this just to make sure I don't make mistakes. You know, I'm putting a video together for you guys. If I make a mistake on it because I didn't check, I will never forgive myself. So I want to make sure that I'm giving you the right answers, and if they're not right, that I figure it out. So if you have the use of a calculator, utilize this as a way to check. These two lines need to be tangent to my function, and they need to be parallel to the other line. I know they're parallel to the other line, so I'm not going to graph the other line because they have slopes of 1/2. I just want to make sure that they're tangent. Gosh, they are. That's beautiful. They're tangent at x equals 1, and they're tangent at x equals negative 3. Okay? So we did our jobs. Find the x-coordinate locations of the locations that f of x has a horizontal tangent. Fantastic. Horizontal tangents have a slope of 0. I want to figure out when does my tangent slope generator generate a tangent slope of 0. That's it. It's all about equations. It's very powerful, the equation here in mathematics. So tangent slope generator, I have to use the quotient rule, derivative of the top times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. Is that equal to 0? Reminder, Don't multiply by the x minus 16 squared. I just need to take the numerator, set equal to 0, to solve a fraction equal to 0. If I have like 0 over any number, that's 0. So I'm just going to not get rid of. I need to remember that 16 is a bad number. I can't plug in 16. I have a vertical asymptote at 16. Instead, just keep that, knowing that 16 is bad. Let's try to solve the numerator set equal to 0. I got 2x squared minus 32x minus x squared equals 0. I got x squared minus 32x equals 0. I could factor x out. I have x minus 32 equals 0. I get x equals 0 and 32. Large numbers, but let's see. X squared over x minus 16. I know I gotta switch my window to be like at least 32, so let's just see. Uh, 64. My goodness. Okay. I can see that at 0, boom, horizontal tangent. Okay. Now, I end up having a vertical asymptote at 16. We can see that at 16, no function value. Okay. If I go all the way to 32, I should be right here where I can see I'd have a horizontal tangent. Boom, right there, horizontal tangent. So I did it. It's a crazy graph. It's very far away with stuff, but that's what it is. We found it. Do the same thing for this. Hopefully the values are not as far away. Horizontal tangents, the slope is equal to 0. I need to figure out when my tangent slope generator generates a slope of 0. Use the quotient rule, derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared set that equal to 0. Just worry about the numerator. 4x squared minus 8x minus 2x squared equals 0. I get 2x squared minus 8x equals 0. Factor out of 2x. I get x minus 4 equals 0. I get x equals 0 and 4. Let's see if I did it. Do x squared divided by x minus 2. And then standard should work. There's 0. And I guess 4 is off the graph. Let's see, 4 is 16, so let's adjust the window to be up here, maybe at like 30. Aha, so 0, I see a horizontal tangent. Now, right here, I see another horizontal tangent. I'm saying that's at 4, and I'm right. Okay? That, my friends, is the product rule and the quotient rule and some applications of them. Hopefully, all of this stuff is making sense to you. The use of a tangent slope generator to generate tangent slopes. It's a very beautiful discovery, and it's a very beautiful thing. Thank you.